Okay, so good morning everyone. Welcome back to the day 2 of this online 5-day session of GATE Enrichment program organized by Computer Science IT Department of BCET. So we hope that you found yesterday's session helpful and insightful. Now today we have Mr. Pulak Maji sir as the speaker of the day. He is an assistant professor of IT department, and today he will be discussing the subject network security, computer network, which is another most important subject for cracking gate. So now over to Pulak sir. Sir, please start the session.
Okay, so good morning, all of you, and all the faculties and our respected directors and all the dignitaries, and most importantly, all the students. I welcome all you for this session. So let's start the session. I'm presenting the slides. Hmm.
Hello. Just
Hello.
click the present. Just click present.
Sorry, sir.
Present. Present.
Present. Click on the present. After settings, a present tab is there. Click on that. Present and then share screen.
Hmm.
Present and then share screen.
Yes. Purva, please add to screen.
Yes, sir.
এটা বড় করা যাবে?
ওটা ওটা তুই এখানে কর। এখানে পিপিটিটা কর নরমাল পিপিটিটা কোথায় গেল কোনটা
এটাই।
স্ট্রিম একটা আচ্ছা এইটা দিন ঠিক আছে ওটা বড় হয়েই ওখানে প্রেজেন্ট হবে তোকে আর পিপিটি খুলতে হবে এটা
এটা কি করবো? Okay, so good morning all. So let's start the session. So today we are going to discuss about the computer network. And in computer network, I am selecting the topic that is IP addressing and subnetting. So this is one of the most important topic as a GATE aspirant. Okay. From this IP address and subnetting, almost in every exam, some questions will be there. And in this session, I am taking also some of the previous year questions that we have solved live. And so let's start the things. Okay. So first of all, before beginning anything, let's discuss what's an IP addressing. IP addressing. Okay. So basically, whenever we want to transfer any data, or whenever we want to transfer any data or send any data from source to destination, then whether it is a LAN network or whether it is a outside the LAN network, we need some kind of address. we need some kind of addresses. Without addresses, our packet cannot travel to the particular destination. So in computer network, we are basically having two kind of addresses. One is a physical addressing, another one is a logical addressing. Okay. So physical addressing means that's we are another name of the physical addressing is a MAC address. MAC address means media access control. Media access control. So MAC address means what? So MAC address basically used to transfer our data from source machine to the next hop. Source machine to the next hop means if my machine is connected to the next router, then how the data will be transferred from my machine to the next router. That is the responsibility of the MAC address. And MAC address is also used to transfer MAC address is also used to identify each computer on a network uniquely, because every computer has its own MAC address. So by using that MAC address, we can easily identify each and every machine that are present on the network. But the main responsibility of the MAC address is to transfer the data from the source machine to the next hop. Hop means here we can consider it may be router. Then from that router to the next router, from next router to after that router. So in this way, it will transfer the data from hop to hop. Hop to hop means machine to router, then router to router, and then router to router, something like that. But the thing is that, in contrast, we are having another address, that is logical addressing, and also known as an IP addressing. That is today's discussion. IP addressing means internet protocol addressing. In this internet protocol addressing, it is also known as a logical addressing. So what we are basically doing this logical addressing, IP addressing or logical addressing, basically used to transfer the data from source machine to the destination machine. How the data will be transferred from the source machine to the destination machine. So there is a difference. You need to understand the difference between the MAC address and the IP address. MAC address is basically used to transfer the data from source machine to the next hop. But the IP address is basically used to transfer the data from source machine to the destination machine. In between, there is no responsibility. There is so IP address basically IP address basically is used to also transfer the data to different network. For example, if the source machine is in different network or if the destination machine is in different network, so how our packet will be transferred from one network to another network, and in that another network in which machine the data will be transferred, this is the total responsibility of the IP addressing. Okay, so now this IP addressing this IP addressing is basically is a 32-bit IP addressing, because we are talking about the IPv4 addressing. In IPv4, as we already know, this is 32-bit addressing. 32-bit means total 4 octet will be there, and in each octet we are having 8-bit, 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 and 8-bit. So total 32-bit IP address is there. Now the next thing is in IP addressing. First, let me show the next slide. This IP addressing is further classified into two types. First one is the classful addressing, second one is the classless addressing, and it is also known as CIDR, that is classless interdomain routing. Okay, so it is further classified into classful and classless. So first you need to understand what is an IP address and what is the need of the IP address. After that IP addressing is in 32-bit IP addressing. This 32-bit we are dividing into 4 octet. What is an octet? Octet means it's a collection of, it's a group of an 8-bit. So 8-bit, 8-bit, 8-bit. So 4 octet will be there, and in each octet we are having 8 bits. So total 32-bit. Now this IP addressing is further classified into two types. That is classful addressing and classless addressing. In classful addressing, what is there in the classful addressing? In classful addressing, we are having 5 classes are there, like A, B, C, D, and E. Classless addressing, what is classless addressing? We'll discuss later after some time. But now we have to consider, or you have to very much concentrate on the how the classful addressing is there. So classful addressing is further classified into 5 classes: A, B, C, D, E. As you can see in this slide, if the IP addressing is an 32-bit IP address, then total how many IP address is possible? You can see total 2 to the power 32 IP addressing is possible. 2 to the power total 32 IP addressing is possible. This 2 to the power 32 IP addressing we are dividing into 5 classes like A, B, C, D, E. Because 2 to the power 32 IP addressing means it's a millions of IP addresses are available. So we are dividing that 2 to the power 32 IP addresses into 5 classes: class A, class B, class C, class D, and class C. And how we are representing this that much of IP address representation? Generally, we are following dotted decimal representation or dotted decimal notation. As you can see, this is the format of the IP addressing where we are writing like that. Dotted decimal means it is in the decimal form, and each decimal is separated with the dotted form. So 128, it's a binary. Hopefully you already know how to convert decimal to binary. 128.11.3.31. So total 128 we are dividing into 8 bit, 11 we are dividing into 8 bit, 3 we are dividing into 8 bit, and 31 we are dividing into 8 bit. So total 32 bit. In this way we are representing. So it is known as a dotted decimal representation. After that, that's we already discussed. Inside the classful addressing we are having total 5 classes are there. Okay, 5 classes means class A, class B, class C, class D, and class E. You have to understand class A, class B, and class C we are generally using in an organization. If your organization is too much big, then you can go with the class A, and then if your organization is not too much big, then go for the class B. If your organization is small organization, then go for the class C. So in real time we are basically using class A, class B, and class C IP addressing. Sir, what about class D and E? Class D and E we are using for the class D we are using for the multicast purpose, and class E we are using for the research and development purpose. So for this reason, these two type of or these two classes of IP addresses we are not using as a we are not using for the general purpose. For the general purpose we are not using class D and class C, but for the general purpose we are using class A, class B, and class C IP addresses. Okay, so now this class full addressing or these classes of IP addressing is this two type. Not it's a two type, actually two part is there. How we are writing this type of IP address? For that we are having two part. As you can see here, two part. First part is known as network ID, and second part is known as host ID. So two part is there: network ID and host ID. Now, network ID and host ID means what? For class A, how many IP address is there? For class A, total how many? 2 to the power 32. So for class A, total 32-bit IP address is there. For among this total 32-bit IP addresses, how many bit is reserved for the network ID and how many bit is reserved for the host ID? So as you can see in this slide, for class A, first octet means first 8 bit is reserved for the network ID, and remaining 24 bits just like byte 2, byte 3, and byte 4, 888, this 24 bit is reserved for the host ID. So see the previous slide, this we are having two part: network ID and host ID. So in that network ID we are having 8 bit. So 8 bit is reserved for the network ID and remaining 24 bit is reserved for the host ID. That is the configuration of the class A, because total 32 that we are dividing into 8 and 24. First 8 bit for the network ID, remaining 24 bit for the host ID. Similarly for class B, what is the configuration of the class B in terms of network ID and host ID? In terms of network ID and host ID, the configuration of the class B is first 2 octet, nothing but first 16 bit is reserved for the network ID and remaining 16 bit is reserved for the host ID. So here we are dividing the 32-bit IP addresses into two parts. First 16 bit or first 2 octet is reserved for the network ID, remaining 2 octet is reserved for the host ID. Similarly for class C, what is the class C configuration or class C division? In class C, first 3 octet means first 24 bit, 8 bit, 8 bit, 8 bit. So 3 octet, and each octet 8 bit is there. So how many? Total 24 bit is reserved for the network ID, and last octet, only the last octet, nothing but last 8 bit is reserved for the host ID. So this is the configuration, and as you can see here, class D is generally used for the multicast address, and class is designed reserved for what purpose? Reserved for research and development purpose. In future, if we need any kind of research purpose or development purpose, any kind of IP addresses, then we can go with this EIP addresses. So class D and class E we are not using, but class ABC we are using as a real-time environment. Okay, so we need to remember class A, 1 network ID, 3 host ID, class B, 2 network ID, 2 host ID, class C, 3 network ID, and 1 host ID. Okay, now you need to understand, so how, suppose for example, if I am giving one of the IP address, then how I can understand, see, this IP address is belongs to which class? That is one of the important questions in the examination they can ask. So how we can identify? Suppose one of the IP address is given. For example, I'm showing one of the IP address to you. Suppose this is the IP address. See the IP address format 128.11.3.31. This is the IP address. Now, if anyone asks you, tell me this IP address is belongs to which class? Class A, class B, class C, D, or E? Which class this IP address is belongs? Then how we can identify? First of all, class identification is very important. Then how we can identify? By looking only the first octet. By looking only the first octet, I can easily tell you this IP address is belongs to which class. By looking only the first octet means only the first octet value, that is 128. 128. By looking of this value, I can easily tell you this IP address is belongs to which classes. Then how we can identify, and what is the first octet value? For that we are having some ranges is there. We are having some ranges is there. Okay, so for class A, see the slide very carefully. For the class A, what is the ranges? What is the ranges? The ranges is from 1 to 127. Actually this should be 1 to 126. Okay, but whatever, but actually the ranges for the class A should be 0 to 126. 0 to 126, but generally we are taking 0 to 127, but generally we are taking 0 to 1 to 126. 0 network we are not using, it is reserved, and 127 network we are not using, or because 127 is reserved for the loopback address or for the testing purpose we are reserved. So 1 to 126, these addresses or these ranges of addresses are belong to class A. So whatever the value comes between in this range, whatever the value, so see this IP address 128 is it there in between this 1 to 126? No sir, is it not there in between this 1 to 126? So this IP address is not the class A IP address. This IP address is not the class A IP address. Then go for the next class B IP addresses. What is the class B IP addresses? Class B IP addresses range is 128 to 191. This is the IP address. Now you can ask one questions that sir, how these ranges we can find out? That I will show you how these ranges with, because these things we can find out. This is not the static. Okay, these things we can find out, but first of all see, then I will show you. So first thing is, what is the range of class B? 128 to 191. Then what is the class C range? 192 to 223. So if any value is belonging to this range 128 to 191, suppose one of the IP address is 140.10.20.3, so only looking the first octet, by looking the first octet, what is the first octet value? 140. So 140 is belonging to which range? Class B, because its range is starting from 128 ending with the 191. So 140 is there in between this value or in between this range, then I can easily say that 140.10.20.3, this IP addresses is belongs to class B. Similarly for class C, what is the range of the IP address? 192 to 223. That is the range of the IP address. What is the class D? Though it is not necessary to remember, but you can remember. So for class D, 224 to 239, or for class C, 240 to 255. So this is the ranges. This is the ranges of the classes of the class A, B, C, D, and E IP addresses. Whatever the value is belonging to these ranges, I can easily saying that by looking only the first octet. By looking only the first octet, I can easily say that this IP addresses is belong to is belong to this class A, B, C, D, and E. Okay, so this is the thing. Next, next is we are having different types of classes as we already discussed. Class A, B, C, D, and E. So what is class A IP addresses? Okay, what is class A IP addresses? In class A, how many IP addresses there? Total 32-bit IP addresses. As we already discussed, 32-bit IP addresses we are dividing into 8-bit is reserved for the network part and 24-bit is reserved for the host part. So 8 and 24. So that's why this thing is written here. The network ID is 8-bit long and host ID is 24-bit long. Okay. Now from here you can find out the range of this IP address. How we can find out the range of this IP address? For one class, if I'm showing you remaining B, C, you can easily understand. So let me. Is it visible? Screen is visible. Hello, screen is visible. Okay, so for the class A, how we can find out the ranges of the IP address. So how we can consider these things. For example, in class A, total how many IP addresses is there? Total 32-bit IP addresses is there. So 32-bit IP addresses we are dividing into 8-bit, 8-bit, 8-bit. So first octet is considering 8-bit. This in this way you can consider 4, 5, 6, 7, 8. Remaining octet, second octet is also considering also containing 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. Third octet is also containing the 8 bits. So I can write 8 bit means 1, 2, 3, 4, 5, 6, 7, 8. And last octet is also considering or also containing the 8 bits. So 1, 2, 8 places 4, 5, 6, 7, and 8. So now in the first octet, what we have to write? It is an 8-bit. It is an 8-bit. It is also an 8-bit. It is also an 8-bit. It is also an 8-bit. Total 32-bit. Now in first octet, what I am already told you, by seeing the first octet, we can easily identify the classes. We can easily find out the ranges. So how we can find out the ranges and how we can find out the classes of IP address? So for that, in class A, the first bit is 0. Always first bit is 0 and it is reserved. You have to remember the first bit is 0 and it is known as prefix. It is known as prefix. So why the first bit is 0? Because millions of IP addresses there. 32-bit IP addresses means 2 to the power 32 means millions of IP addresses there. So among all these IP addresses, how we can understand if any of these particular addresses is belong to class A or any of the particular addresses is belong to class B or class C, something like that. How we can identify? So to identify that, what we are basically using the prefix concept. For class A, first bit is reserved for the prefix. And what is the first bit value? 0 is the first bit value. So this is reserved. This is fixed. We cannot change. This value is fixed. So what about the remaining 7 bit? Remaining 7 bit value we can change. We can change means if I am taking minimum value. So what will be the minimum value? 7 bit minimum value means 70. So I can take the 70. So I can take the 70. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So first bit value is 0, that is prefix, and remaining 7 bit minimum value will be 70. Similarly, what will be the next value? Next value will be 1, binary 1. So how we can write the binary 1? 3, 4, 5, 6, 7, and last bit value is 1. Similarly, in this way, if we moving, then what is the last value? Last value will be 1, 1, 1, 1, 1, 1, and 1, 7, 1, and this zero is there. This zero is there because it's totally the combination of the 8-bit combination. So what will be the first bit value if we convert this into a decimal? So 80 means what? 80 means 0. 80 decimal means what? 80 decimal means 0. And what about the last? This is last address 71 and 0 is there as a prefix value. Then what is the last value? This value will be 127. If we add, hopefully you already know how to convert binary to decimal. I'm not going into that part. So 80 means 0 and 071 means 127. So 0 to 127 is the range of the class A IP addresses. But the first address, that is 80, we are not using because it is reserved. IANA is the organization. If I'm writing the name of the organization, Internet Assigned Number Authority. If you hear this name, this is the organization who are basically responsible for maintaining the IP addresses. Okay, who are basically responsible for maintaining the IP addresses. So this organization decided that 0.0.0.0, nothing but 0, first network ID we cannot use, it is reserved. And the last address, that is 127 address, we also cannot use because 127 address we are using as a loopback address. What is the loopback address? Loopback address means just for testing and diagnosis purpose we are using. So then actual ranges of the class B will be 1 after 0, 1, 2, 1 2 from where? 1 to 126, because 127 we cannot use. So before 127 I have to stop. So actual range of the class A address will be 1 to 126. So whatever the value will be present or will be there in between this 1 to 126, I can directly say that these IP addresses is belonging to class A IP address. Okay, so class A IP addressing. So similar, that's the same thing is written here. The same thing is written here. You can see what is the value, actual range. See the last line. See the last line. This is I'm marking for you. What is the IP addresses belonging to class A ranges from 1 to 126. 1 to 126, that we are finding here, 1 to 126. And how we can finding it is very easy, by looking only the first octet. By looking only the first octet and by applying this method, I can easily find out the ranges of the class A IP address, that is 1 to 126. That is the first point you need to understand. Second point is what? Second point is what is the subnet mask? Subnet mask means what? Or what is the masking? Masking is also important. What is the masking actually? In class A IP addressing, the subnet mask will be 255.0.0 and .0. Sir, what is the subnet mask? Subnet mask means whatever the network ID or whatever the octet is reserved for the network ID. In class A, how many octet is reserved for the network ID? First octet. First octet means how many bit? 8 bit. So in that first octet or in that 8 bit, if I am putting 8 1 2 3 4 5 6 7 8. So if I am putting the 8 1, what is the 8 1 value? Binary or decimal value? 8 1 is a binary to decimal. What is the 8 1 value? It's a 255. So that's why 255. So subnet mask means whatever the network ID is there, if I am using all those network ID value as a 1, then it comes out to be a 255. And what about the host bit? These the remaining 3 octet is reserved for the host. These 3 are the reserved for the host, and host bit value will always be 0. So that's why 0, 0 and 0. So that is the subnet mask. Similarly for the class B, in class B, how many octet is reserved for the network? First 2 octet. So 255.255.0.0. In class C, how many octet is reserved, or how many octet is reserved for the network ID? First 3 octet. So first octet 255 because 81. Second octet 81 255. Third octet 81 255. And last octet is 80 because last octet is reserved for the host ID. So you have to put the 80. So 255, 255, 255, and then dot 0. So these things you have to remember about the class B, and then class C, class A, then class B. Class B ranges is what? Class B ranges is 128 to 191. Or hopefully you can find out. How we can find out in class B? In class B, what is the prefix value in class B? So I am showing you. In class B, first 2 octet is reserved for the network ID. Host ID part I am not taking because host ID is not necessary to find out the range. To find out the range, we are only, or we have to only use the network ID part. So in class B, first 2 octet is reserved for the network ID. So that's why I am taking the first 2 octet. But how to find out, sir? It's very easy. First of all, we need to take the prefix value. In class A, what is the prefix value? 0. Similarly, in class B, what is the prefix value? 10. 10. So this is reserved. This 10 is reserved. This 10 is reserved. But remaining, how many bit is remaining? Remaining 6 bit in first octet. 1, 2, 3, 4, 5, and 6. 6 and 2, 8. And this octet is also reserved for network ID. So that's why this 8 bit also you need to consider. 3, 4, 5, 6, 7, and 8. So now this 2 bit is reserved. So now we need to what? We need to fill up the next value. We need to fill up the next value. So what will be the next value? 0, 6, 0, 1, 2, 3, 4, 5, and 6. Only the 6. What? So to find out the ranges, we have to see only the first octet. So first 2 bit value is reserved, that is prefix value 10. Remaining 6 bit initial value, minimum value. What will be the minimum value? 60. Then what will be the minimum value? 1. So 0, 0, 0, 0, 0, 1. Then what will be the last value? In this way, if we move, then what will be the last value? 1, 1, 1, 1, 1, 1. And this 10 will be there. This 10 will be there. 10, and this 10. So what it comes out? This comes out 128. This comes out 128. And what will be the last value? This comes out will be a 191. So what is the range? See, the same thing is written at the bottom of this slide, that is 128 to 191. So whatever the value will be given, or whatever the value will be there in between this range, then I can easily say that if this IP address is belong to class B IP address. Class B IP addresses. Okay. Similarly for the class C, same. In class C, what is the ranges? 192 to 223. Okay, that is very basic. Hopefully you can easily find out. In class C, how many bit is reserved for the prefix? That is 110. And then remaining 5 bit you need to apply the same process, just like class A and B. If we applying the same process, then you can easily find out these ranges will be there. Okay, 192 to 223. And see the class D and class C. Class D, as I already discussed, it is used for the multicasting, and class C is already used for the experimental and research purpose. Okay, that we are not using as a real-time environment. Fine. Now the next thing, this table is important. This table is important because this table is showing to you in class A. See, leading bit. Leading bit is what? Leading bit means it's a prefix that you are considering. If we are considering the leading bit, then only we can find out the ranges. So in class A, what is the prefix? 0 is the prefix. In class B, what is the prefix? 10 is the prefix. In class B, what is the prefix? 10. In class C, what is the prefix? 110. In class D, 1110. In class C, 41. Although class D and we are not using, but still you need to know. Then net bit. Net bit, as you already discussed in class A, first 8 bit is reserved for the next net bit. Class B, first 16 bit, nothing but 2 octet. Class C, first 3 octet, nothing but 24 bit. And class D and class E, it's not defined. Similarly, how many number of network, how many number of hosts, and what is the ranges? See, 0 to 127 for class A. Class B, 128 to 191. Class C, 192 to 223. Class D, 224 to 239. And class E, 240 to 255. These ranges is important. You need to remember these ranges. Okay. Now the questions is coming. These questions I am taking from the previous year GATE, and also some of the questions will be there from the UGC NET also. Okay. So this question has been asked in NET NTA NET to December 2018. Very easy question. The question is saying that the 4-bit IP address consists of 4 options will be there: network address, neither network or host address, and both network and host address. So what will be the answer? Hopefully all of you is very much aware about this, or always very much. It's very easy question actually. Okay, it's very easy question. Nowadays this type of question they are not asking, but still you as it is a previous year question, so it is important. So the 4-bit IP address consists of the both network and host address. What will be the correct answer? Correct answer will be the option 4. 4 is the correct answer, both network and the host address. Okay. If any of you are having any question, then please write your question on the chat box. We'll try to answer the questions at last. Okay. The 4 byte of IP address consists of the both network and the host address. Next is what this question is very important. This is also previous year question. This is actually gate question. Okay. The question is the IP address dash is used by host when they are being booted. If any of the host, if a host means any of the computer I can consider, if any of the hosts, if they are booting for the first time, then which IP address they are using? 4 options is given: 0000, 1.0.0.0, 1.1.1.1, and 255.255.255.255. So what will be the correct answer? Correct answer will be 0.0.0.0. This will be my correct answer. So you need to remember, very important question. This previous year questions, maybe it can be repeated. So for being booted, or if the system is booted for the first time, then the IP address that we are using, that is 0.0.0.0. Okay, so that is my correct answer. Option 1 is my correct answer. Now this is the another question. Which of the following class of IP address has the last address as 223.255.255.255? So for that reason only you have to remember the ranges. See, question is very interesting question. It is asking for, tell me the classes in which the last address is 23.255.255.255. So what will be the answer? For if I'm taking all these option in class A, what is the starting address? 0. What is the ending address? Means ranges. What is the range first address? 0 to 127. So it is not ending with 223. Okay, class is not, it will be not my answer. Then go with the class B. What is the class B ranges? Class B ranges start from 128 and it is ending with the 191. But 223, then 223 is not my, it is ending with the 191, so 223, it is not matching, so it is not my answer. Then class C, option 3. In class C, what is the starting address? Starting address is a 192, and what is the ending address? Ending address is a 223. Yes, 223. And it is also asking for the last address. In class C, the last address is what? In class C, the last address is a 223. So that's why option C or class C will be my correct answer. So option 3 is my answer. Okay, so it is also showing class C is my correct answer. Now next question. It is also previous year question. All are the previous year question, but it is also previous year question. Number 4 question. Hopefully you are solving. Yes. So it is also previous year question. The question is saying that consider the following two statement with respect to IPv4 in computer network. What is the two statement is given? The loopback address is a member of class B network. The loopback address is a member of class B addresses, and the loopback address is used to send a packet from host to itself. So now the 4 options is given: P true, Q false, P false, Q true, P true, Q true, and P false, Q false. So see the statement very carefully. The statement is saying that the loopback address is a member of class B. Whether it is a class B member? No. Loopback address, the address is 127, and 127 address is belonging to class A, not the class B. Class B addresses will be started from the 128. So loopback address is always the part of the class A addressing, not the class B addressing. So P statement is wrong. If the P statement is wrong, then 1 cannot be my answer and 3 cannot be my answer, because in both these options P is true. So these two options we can eliminate. Now go with the next option. Also go with the next statement, Q. The loopback address is used to send a packet from host to itself. Yes, the loopback address generally used to send a packet from host to itself. This statement is true. this statement is a true. So what will be my answer? My answer will be P statement is a false and Q statement is a true. So this statement based question is very important nowadays. They are giving some kind of statement and then they are asking whether both the statements are true, whether one is true, two is false, whether two is true, Q is false, or both are false. So this type of statement based questions is very important. So you need to very much careful. Okay, now these are all about the class full addressing. These are all about the class full addressing. Now, as we already discussed, the addressing is generally two types: class full addressing and classless addressing. So in class full, we are having different classes. In that classes, different ranges are there. If each and everything is there. But why in today's scenario, why we are not using the class full addressing? Because in classful addressing the main problem is the wastage of an IP addresses. In classful addressing the main problem is what? The main problem is the wastage of an IP address. How the wastage will be there? For example, I'm giving one of the example. In class A, let me tell you, in class A, how many addresses is there for the host? Host means how many IP addresses we can use in a real-time environment, or how many IP addresses we are using or we can using in a PC, in a computer. How many IP addresses? So in class A, we can use 2 to the power 24 IP addresses. 2 to the power 24 IP addresses we can use as a host address. See, 2 to the power 24 means it's a huge number. It's a huge number. That many IP addresses we are having. Similarly, in class B, how many IP addresses is there? In class B, how many IP addresses is there for the host ID? 2 to the power 16 IP addresses is there for the host. Means this many IP addresses we can use as a host machine. Similarly, for the class C, how many IP addresses is used as a host machine? That is 2 to the power 8. Now, if we consider this scenario, suppose you need only the 300. You need only the, for example, I'm telling to you, if we need only the 300 IP address. If we need only the 300 IP addresses, then which class of IP addresses you are using? Which classes IP addresses you will take? Class A, class B, or class C? Because I need only the 300 IP addresses. So if I am going with the class C IP addresses, then in class C, how many IP addresses will be there? 2 to the power 8. That is 256 IP addresses will be there. 256 IP addresses will be there, but from this 256 we have to minus 2. Minus 2. What we are why we are doing the minus 2? Because first IP addresses is used for the to identify the network, and last IP addresses is used for the to identify, or basically used for the broadcast address. So that's why these two IP addresses we are not using as a real time. So that's why we have to do the minus 2. So total how many usable? How many? 254. But the thing is that how many I need? How many I need? I need only the 300 IP addresses. So can I use this class C IP addresses? Because my need is greater than the availability. Available. How many is available? 254. How many I need? 300. So I cannot use the class C IP addresses. So can I? Then I have to use either class A or either class B. So if I am using the class A IP addresses, then observe 2 to the power 24 means it's a million. It's a huge amount of IP address. From that I have to take only the 300. So how many it is wastage? Huge number of IP addresses is a wastage. Similarly, if I am using the class B, 2 to the power 16, here also it is, maybe it is a 16,000 some number will be there. So from that amount of IP address, if I am taking only the 300, see, you can observe or you can think how many IP addresses are wastage. Or moreover, I cannot take the class C IP addresses also. So that is the main problem of the classful IP addressing. Classful IP addressing, the wastage of the IP addresses is too much. That's why we are in today's scenario, we are not using the class full IP addressing. We are not using the class full IP addressing. We are using the classless IP addressing, and that is also known as CIDR. That is classless inter-domain routing. Okay, so hopefully it will be clear to you why we are in today's scenario, why we are not using the class full addressing. So my next topic will be the classless addressing. that is also known as a CIDR, that is classless interdomain routing. Okay, so if we read this point, it is very much clear. Classless means what? Classless addressing is in improved IP addressing. Obviously, why it is improved? Because in classless, what the advantage we are getting here? The advantage we are getting that here the wastage of the IP addresses is not there. Here, if I need the 300 IP addresses, then I can easily get the 300 IP address. That means efficiency is there. It is more efficient than the classful addressing. If I need the 500 IP addresses, I can easily get the 500 IP addresses. So that's why, because so the main benefits we are getting in classless is here we are getting the efficient usage of the IP address. Here wastage is not there. So that is the main and the primary usage or primary reason why we are using the classless addressing. Next, what is written here? It makes the allocation of the IP address more efficient. Already told you, allocation of the IP address. If I need the 500 IP addresses, I can easily get the 500 IP addresses. That the allocation is very much efficient. What is the number 3? It replaces the older classful addressing. It's very easy and it is also known as a CID. That is classless interdomain routing. Now, how to represent this CIDR, or how to write down the classful addressing? Because classless addressing. Because classless, the name is itself saying that there is no class. There is no class. So how we can? So rules. I am coming back, but let's look at this slide. How we can representing the classless addressing? So classless addressing, we are representing something like in this format. This is very very important. Something in this format. What is the format? The format is a dot b dot c dot d. This is the four a dot b dot c dot d means this is the IP addresses. Now slash n. This slash n is very very important. This slash n is very very important because this slash n is representing the marks. This slash n is basically representing the marks, or it is also representing the number of network. It is also representing the number of network of this IP addresses. How many number of network bit is there? How many number of network bit is basically there? That is representing by the slash n. So first of all, it is representing the marks, or it is representing the how many number of bit is reserved for the network ID or for the network bit. So if we see the example how we can writing this CIDR notation. So if we have to write in this format only. So first is 128.0.1.2. It is an IP addressing. Slash 28. What is the meaning of slash 28? Slash 28 means 28 bit is reserved for the network ID. 28 bit is reserved for the network ID. It is clearly written here. 28 bit are used for the network ID or identification of the network. Then the next question will come that how many bit is reserved for that host ID. So total how many bit of IP addresses will be there? 32 bit IP addresses is there. Then how many bit is reserved for the network ID? Obviously 28 bit is reserved for the network ID. Then how many bit is there for the host ID? Only the 4 bit is there for the host ID. If the 4 bit is there for the host ID, then how many host is possible? The next question. See, one by one question will come. If the 28 bit is reserved for the network ID, then how many bit is reserved for the host ID? It is very simple. 32 minus 28, 4 bit. If the 4 bit is reserved for the host ID, then how many host is possible? Very simple. How we can calculate? 2 to the power 4. Total 16 host or 16 host is possible. 16 host is possible in this IP addresses. Okay, so this is the basic things that we need to understand how we are determining or how we are defining the classless addressing, or moreover CIDR notation how we can write in classless. Actually there is no concept of class. Actually if we see this 128 here, no one asking you if this IP address is belonging to which class, because it's a classless. Here we are not having any classes like A, B, C, D, E. Here we are not having any classes. So here no one asking you the classless, or no one asking you the what is the class. Here the main funda is, because here we not using any class. Here instead of class we are using the block number. We are using the block, because in class less addressing how we can representing the IP addresses. First we are using the block number, B number I am writing, and second is the host number, yeah, host ID, age ID. Okay, in class full addressing, how we can representing network ID, host ID. But here we are using, or we have to use, or we are using block number and host ID. So here no concept about the classes. Here we are using the new thing, that is the block. How many block will be there? So that if I am having two blocks, so I am assigning these two blocks to different parts. So block number and host ID will be there. So hopefully this is clear that how we are representing this C idea, and what is the most important is slash value, slash 28. Whatever the value is written in front of this slash, that means how many bit is reserved or not reserved, how many bit is used for the network ID or network part. Okay, so that is the C idea notation and how we are using this notation in class place addressing. Now one of the questions will come from this C idea notation. They are asked, this is the previous year question, they are asking that given the C idea representation, one of the IP address is given 20.10.30.35 slash 27. Find the range of the IP addresses in the C idea block. It is asking for the ranges. Find out the ranges. So how we can find out? I am showing you how we can find out. So first of all, what is the procedure? First of all, write down the questions. What is the question? What is the IP address is given? 10.20.30. and 35, and slash how many bit is reserved or how many bit is used for the network? 27. It is very much clear. 27 bit is reserved for the network bit, means this 20 means how many bit? This 20 means what is the first octet value? 8. This is the decimal representation, na? But actually this is first octet, 8 bit. This 10 also 8 bit. This 30 also 8 bit. This 30 also 8 bit. I have to take the 27 because as we already know, we cannot disturb the network ID bit, because if we disturb the network ID bit, then total concept will be wrong or total things will be suddenly changes. Okay, so we cannot disturb our network ID or network portion. We cannot disturb. Whatever the work we have to do with the host part only. So 27 means what? 27 means 27 bit is used for the network ID. So now first is 8 bit is reserved, 8 bit, 8 bit, 24 bit is there. Now we need the 27 and we already got the 24. So more 3 bit is required. So more 3 bit I have to take, or I have to borrow from this last octet. From the last octet I have to borrow. So I have to borrow from the last octet. Then how I can borrow? See the solution. See first of all they what they did, they did what? 20 is there, they are opening this 20 in the 8-bit format. Then 10, they are opening this 10 as a 8-bit format. Then 30, they are opening this 30 in a 8-bit format. Then 35, they are opening this 35 in a 8-bit format, and last 27 is there. Now 27 means what? Number of network. So number of network means what? This 8-bit, this 8 bit we have to take, this 8 bit we have to take, this 8 bit we have to take. Then how many bit is there? 8, 8, 8, 24. But how many we need? 27. So more 3 bit is required. More 3 bit means this 3 bit value I have to borrow from the last octet. So if I am borrowing this 3 bit value, then 27 bit is borrowed. Yeah, 27 bit is there for the network part. Then remaining how many bit is there? Remaining 5 bit is there. So I have to change, or I can change this 5 bit only, not the previous 27 bit. As I already told you, 27 bit I cannot disturb because it is the part of the network. So that's why I cannot disturb. So how many bit is there for the host? Only 5 bit. So I can work on only this 5 bit only. So how we can work? See the first IP address. So up to here we cannot disturb anything because this total thing is 27 bit. So remaining 5 bit, what is the 5 bit minimum value? 50. And what is the 5 bit maximum value? 51. So now if I'm converting this total, then it comes out to be a 20.10.30. This value to same because this 888 bit is same. Last octet value comes out to be 32. That is my first IP address. and if we converting the last IP addresses, then it comes out to be a 20.10.30.63. This is the last IP addresses. So this is the ranges 32 to 63. This is the ranges, and question is asking the same. Na? What is the question is asking? Question is asking the find the range of the IP addresses in the CIDR block. So what is the ranges? The ranges is 32 to 63. So in this way, you have to find out that how we can find out the ranges of the ranges. Find it very important. One of the IP address they are given, and they are asking the find the ranges, not the ranges. They are asking the what is the first IP address, what is the last IP address, what is the second IP address, what is the fourth IP address. So in this way they can ask some questions. So this thing is very important. Okay, now the next thing is subnetting and subnet marks. Okay, now what is the subnetting actually? So subnetting is a very important concept. What is the meaning of subnetting? Subnetting means dividing the larger network into a smaller network. That's the simple definition of the subnetting. If we are having the big network, so what is the problem of the big network, sir? Why we are dividing the big network? Because to maintain the big network, it's very much difficult. If your network is too complex, or although it is a very big, then to maintain or to manage those networks, this PC, computer, cables is very much difficult. So to reduce this difficulty, what we basically did, we are dividing that big network into small network. So that small network, the process of dividing the small network is known as a subnetting. The process of dividing the small network. So we are dividing. Well, we are having one large network, so we are dividing. Thus, divide the network into some piece of block. So that process is known as a subnetting. Okay, in subnetting also we can do in classful addressing, also in classless addressing also. Okay, so this is a subnetting. Just you need to remember, divide the larger network into smaller network. Why we are dividing? Because to maintain the larger network or to manage the larger network, it is very much difficult in a real-time environment. So that's why to do the simplicity, or for the simplicity, we are using the, or we are basically doing the division of the larger network into the small part, or small network. That the process of dividing is known as a subnetting. Okay, that is the simple meaning of the subnetting. Now here it is giving some kind of IP address and some kind of subnet marks, and the here we are having some kind of questions is there. Key, it is previous year question. How the subnetting is ruled. So I'm showing you how the subnetting is actually working. Then we'll solve this question. Okay, suppose for example, I'm having in here, I'm showing how the subnetting is look like. Okay, so for example, I'm having one of the IP addresses. Subnetting, how we can perform. One of the IP address is there, 200.10.20. This subnetting I am showing in the in case of classful addressing. Okay, 200.10.20.0. This is the IP address. This is the IP address, or this is the network ID I can consider. And these IP addresses we have to divide. These IP addresses we have to divide it into some part. Some part we have to divide. Okay. So now how we can divide this IP addresses or this network? Because subnetting means what? Dividing the larger network into smaller part. So I'm taking one of the example. Just we need to divide this network into smaller part. So what is the process? Just process I'm showing to you. Hopefully remaining you can easily understand how we can dividing. So suppose this is the network I'm taking. This is the network I'm taking. In this network, what is the network ID? The network ID is 200.10.20.0. This is the network ID. Now I have to divide this network ID. So how we can divide the network ID? How we can divide the network ID? Just simply what you have to do, very easy. Okay, very easy. What we have to do? Just see. Just write down the your ID 200.10.20. 200.10.20, and then what you have to do? This is which class of, first of all, because we are doing the subnetting in a classful addressing. So if it is a classful addressing, then I can easily find out which class it is belong to, Hopefully all of you know this is belong to class C, because the ranges only see the first octet. First octet range is what? 192 to 223. So 200 is coming in this range. So I can easily say that it is a class C IP addresses. If it is a class C IP addresses, then what is the subnet marks? What is the subnet marks? Subnet marks of the class C IP address. Hopefully all of you know how many network is there for the class C IP addresses. 3 network, 1 host. So if it is a 3 network, then 255, 255 dot 255 and dot 0. So this is the subnet marks of the class C IP addresses. Very simple, very easy. Hopefully all of you are able to understand. Now if it is if this is the subnet marks 255, 255, 255 means this first 3 octet are reserved for the network part, network ID. So that's why 200.10.20 this is also reserved for the network part. This is also reserved for the network ID. We cannot disturb this 3 octet. So what is the last octet? Last octet is only there for the host part. That part or that octet only I can work. So I have to work only that octet, only the last octet. Okay, so what is the last octet? Last octet is a 0. So now I'm writing the last octet value 0. It is originally it is giving 0. So I'm writing 80. Just I have to open 30, 40, 50, 60, 70 and 80, because I can work only this last octet. Remaining 3 octet I cannot work, because these 3 octet are reserved for the network part. How I can identify this is network part? Because this is a class C IP address. In class C IP address, first 3 octet is reserved for the network. That is a simple concept. Now see the last octet. What is the last octet? Because last octet original value is decimal 0. So if I am writing into a binary format, then it will be a 80 in binary. Now how we can divide this network into 2 parts? So observe very carefully. Just what you have to do, you have to fix the first bit value. Very important. This bit, only the first bit value you have to fix. So if I'm fixing the first bit value, then automatically your network will be divided into 2 parts. Very important. If you are reserving the first bit, only 1 bit, if you are reserving this only 1 bit, then automatically your network will be divided into 2 parts. I'm giving the name. First part I'm giving the name S1. Second part I'm giving the name S2. Automatically it will be dividing into 2 parts. Okay. Now let me complete the S1. S1. Then if it is a reserve or fixed, then it is reserve. This value I cannot change. Then what will be the remaining value? 0, 0, 0, 0, 0, 0, 1. Then it is 2. Then it is 3, 4, 5. In this way, if it is moving, then what will be my last address? 0, 0 will be there as it is. 0 will be there as it is. And then it is 7, 1. 1, 2, 3, 4, 5, 6, and then 7. So now if I'm finding the ranges, so ranges, what will be the ranges? Ranges will be 200. So as it is will be there 200.10.20.0 to last bit value or last IP address. What will be the last IP address? 200.10.20, and what will be this value? 71 means what? 71 means it's a 127. 71 means it's a 127. So this is the range of the S1 subnet. We are creating the 2 subnet. So what will be the range of the S1 subnet? 0 to 127. 0 to 127 is the range of this IP address. But among this 0 to 127, this 0 network or 120 last IP addresses or first IP addresses we cannot use. All we know, because first IP addresses is basically used to identify the S1 network, and last IP addresses is used to identify the broadcast address of that network. So actually from where I can use? From 1 to 126. So total how many usable host will be there? Only 126. In S1 subnet only 126 host will be there, usable host will be there. Similarly for the S2, let me remove it. Similarly for the S2, how we can find out the S2? S2 how we can find out. Okay, so how we can find out the S2? Let's wait for a minute. How we can find out the S2? क्यों नहीं? কতক্ষণ বেরিয়ে গেল? আমাকে আগে বলুন। কি হয়েছে? Yeah, মুশকিল ব্যাপার কি বলবো